Hello, good evening, everyone. Okay, here we go. Okay, so Jatin again. In today's session, I'm going to discuss about a very popular module in Python called as Numpy. Now, there are several reasons we are using Numpy in this particular session. Reason being is Numpy is fast, Numpy is better, Numpy provide you so many arithmetic operations as well as functions which are required for mathematical presentation of a data. Again, in my last session, I have discussed about Anaconda, in which we have seen how to install Anaconda into your machine. So NumPy is one of the module which is provided by Anaconda. So if you are using Anaconda, might be a Jupyter notebook, or you can use in IPython. You can import NumPy and use it into your data analysis. Now, in this particular session, I'm going to discuss about a couple of things. This is going to be a little bit big session, so I prefer to divide it into two different parts. So I try to record first part today, and maybe I can record the second part tomorrow. So let's start discussing about what is exactly a NumPy. So NumPy is a numerical pi. Okay, here we go. NumPy is a numerical pi. It's a module, or I would say a package in Python, which are required for numerical analysis of a data. And this is one of the important module if you're looking Python toward data science perspective, because NumPy provides you a number of functionality to do the operations between their data set and utilizing to develop an algorithm using it. NumPy is fast. It's pretty fast as compared to Python. In fact, in my next slide, I have given some example in which you can see the difference between NumPy and normal Python, and you realize that NumPy is almost 90% faster as you compare with normal Python operation. So what our slide says, our slide says NumPy is an extension to Python programming language, adding support for large multi-dimensional array and matrices along with a large library of high-level mathematical functions to operate on these arrays. Now, NumPy is a project which was started by Travis, and more than 200 developers are contributed towards its development. And in 2006, its first version was launched as a part of a GitHub project, and it became so popular since then. Now, NumPy is a module which every data scientist should know. Everyone who want Python to use as their day-to-day regular algorithm work should know about this. Now, NumPy is not available in normal Python, raw Python, but it comes along with Anaconda. So if you want to install, if you're using any raw Python, I discussed about the difference between raw Python and Anaconda in my last session. But in case if you want to install NumPy into your machine, you have a command available called as pip. You can use pip, or I can use directly NumPy setup install once we download the module. We have discussed about how to install the modules into our namespace in our last session as well. But prefer to use Anaconda because it provides you NumPy defaultly available to your machine. So the official website of NumPy is numpy.org, where you can find out a lot of documentation to read about. I am just copying a couple of things from that particular document and put it there into my slide and show you to some demonstration how this NumPy actually works with the data. So NumPy is an open source. It is licensed under BSD license, and you can reuse it. Just have some restrictions over it. And it, as I said, it was developed first by Travis, and more than 200 developers are actually contributed to a project. The latest version of NumPy is 1.14, and this is one of the popular module in PyPI in Python index, and you can see almost 200,000 downloads. 200,000 downloads. It's a huge amount every month here is happening on NumPy. So let's try to explore this module. So like it started with, I have a few tests which I have written over here actually. So this is a screenshot I have taken of one of my program in which I try to calculate a time taken by a Python to take a sum of 10,000 numbers only, and the similar operation I have done with the help of NumPy. And The result is completely amazed you that normal Python approximately did 20 seconds to do this job, but NumPy eventually took only 0.1617 second. That's a huge difference. Now, the reason of using the NumPy for having much faster as compared to Python is, first thing is NumPy is built on C, so it's more low level side of it, and it's provided you the functions which is mostly built on C for using in Python. So for Python programmer, it becomes pretty good in terms of speed, as well as it's utilizing the C feature. And apart from this, this NumPy is also not supporting GIL, which is global interpreter lock. So you can it runs multiple thread and do this job in much more faster way as compared to normal Python. So this is about a performance test of NumPy. As I said before, it's much faster as compared to Python. In my case, in this particular slide, it is almost 90% faster as compared to normal Python. Now let's try to explore it. So this is my CMD. I try to invoke IPython. Now IPython is a utility which I got when I installed Anaconda in last session. Once I import IPython, I start importing NumPy module and start utilizing it. Now everything I mentioned in a slide, but I want more in execution so that we can understand out of it. So the very first thing, if I want to utilize this NumPy, I have to import it. So I'm importing it. So I say import NumPy as np is my first command. Once I run this command, I imported NumPy into my current namespace and I start utilizing it. So the centric part of NumPy is basically an array. Like for example, in Python, when you read Python, you have find multiple kind of structures like list, tuple, dictionaries, or might be a set, integer, or string. Similarly, in NumPy, there are two favorite, I would say, two centric data structure you have is called as array, which we normally call as ND array. N numeric, no, N is numeric, D for dimension array, and followed by a matrices. So you can create an array or a matrix. You can create multiple dimension arrays and process our data utilizing this NumPy. We are going to see it into today's session. So let's get started first. First, I need to check it out what version I have. So I say version, it gives me the version of NumPy. Oops, what happened? Okay, I forgot to give underscore underscore. So I'm currently using 1.13.3. It's a current version of NumPy I'm using. It comes along with Anaconda installation. So I did not install it. If I want to install it manually, hopefully I get it 1.14. But no such much differences as you compare 1.13 or 1.14. So we are using this version. I hope that you have a similar kind of version and you don't face any issues while executing the commands. Let's proceed further. As I discussed that NumPy is the most centric part of NumPy is an array. So how to create an array in Python? So if I want to create an array, I define a name of it called as a as a NumPy dot array. Okay, and I give some list inside that. So array is a function which NumPy provide. It accept either a list or either a tuple. You can provide any of the structure you want, and it basically creates an array for you. Now, like if you know about Python list contains an arbitrary structure in which you can have a combination of string, you can have a combination of numbers, which is integer, and you can also have a combination of floating value. But if you talk about NumPy array, all the data here, the element of this particular list should be of a similar type. If you want to specify this, you can specify this with the help of this is called as int. Okay, now I have created an a in which all the elements which are available over here, it's of integer type. You cannot have a NumPy array in which you have an arbitrary object, one integer, other list, oh sorry, one integer, other floating value, or third is what I can say, a string value. You can have a similar kind of structure. If you want to change a structure, you can do that. Let's say for example, you can also specify d type equals to float. Now I create an array which have a floating value. So I can specify a string here, I can specify integer here, whatever the type I want to store, I can store it into my array. Once a is created, it's similar as you can apply a similar kind of operation. So let's say for example, I say a, I get this array out of it, which contains actually three different elements. Uh, if let's see some examples over here. I just put it over here like this. First thing is, let's say, what is the type of a? The type of a. The type of is ND array. As I said before, that array is nothing but an ND array of a NumPy module. So it gives me that this is A is a NumPy array. And if I try to access any specific index, so let's say for example I say print A of 0. A0 will return the index number 0. So what is the value at index number 0 is 1.0. Similarly, A of -1. So whatever you have done before, you can do it with the NumPy array. So this is an index number 0. This is the index number 1. This is the index number 2. And you can also do it in a negative way. This is index number -1, -2, and -3. Let's do it. So it gives you, it's a third one. So I say -1 is a third one. There's some more data. If you see dir of NumPy or dir of it, you can find a lot of functions are available over here. So we are going to utilize some of the functions as well as data in this particular class. We are going to discuss about a couple of functions here. So let's get started with a d type. So I say a dot d type. Remember, when we have created an array, at the time I specify what is the d type of this particular element. So at the time I have taken float, so it gives me what is the d type of every element it float. The second one I have is a dot item size. Item size. Item size will give me the size of each and every item I have inside my array. Normally for floating it is 8 bytes, so it gives you 8 bytes. Now, every time when you store a data into your array, it stores in a form of some shape, some dimension. So first, the another function we have is called a shape. Shape will exactly give me the shape of my data. Now, here we have a single dimensional structure. Now, if I talk about A is a single dimensional structure. Now, if you say a dot shape, it gives you two parameters: the total number of rows and total number of columns. Now, in my case, I have three total number of rows, but I don't have any columns, so it gives you 3 comma. But if your dimension get increased, in which you have 3 columns and 3 rows, then I give you 3 comma 3. If you have two rows, 3 columns, it give you 2 comma 3. So we discuss about the multi-dimension arrays going further. You can also say a dot size. Size is the total number of elements which is available over here, called as size. Now, I say a dot size, it give me the size of the total number of items I would say available in my array. Now you can also apply a length function. Length is give you the total number of length, which is also 3 again. So there is a difference between a size and a length. Let's say the total number of objects are available inside my array. Size will give me the total number of items which are available inside my array. It become more understandable when we discuss about a multi-dimensional array in which we have more items and less objects. At a time you understand what is the difference between a size and a length of an array. We come across with more functions. The next one is number of bytes. So I say n bytes, and I just took it. Okay, here we go. I say n bytes, so I say n bytes. N bytes will give me the total number of bytes a complete array holds in a memory. So it's 24. As I said, that every item size is 8 bytes. So 8 plus 8 plus 8, total 3 items we have, so it become 24. Now I have a. Okay. Now I say a dot. There is a function called as fill. Fill basically provide this value. Now I say 10. It basically fill this value by 10. Now here I provide an integer value, but the d type of my element was a float. So it takes 10.0, 10.0, 10.0. Each and every value is filled by 10. Now I can also do the slicing here. Let's say 2 colon. I want to see all the values after 2, which is only one value I have, which is 10. So it gave me a new array which holds a value 10. So it's pretty similar as compared to list, but it provides you the faster data structure to process any data, and it provides a lot of functions which we are going to look further. Let's say for example here I define 2 arrays. So I say numpy dot array. I give some values to it. 1, 2, 3. Okay, I define one more array called as b, which have some values to it. Let's say 4, 5, 6. Okay, now I have a ready as well as b ready. Now I have 2 array, both are having the shape, which is 3 comma. So if you say a dot shape, is 3 comma, it's a b dot shape, it's again a 3 comma. Both are having the same shape. Now, if both are having the same shape, you can apply the arithmetic operation between them. Like for example, a plus b, it gives you the addition of it. Now remember, when you discuss about a list, if you say a list plus b list, it does the concatenation. But the beautiful part about NumPy is it works with each and every element. So here when you say a plus b, what it does, it takes the first element, added with 4. Take the second element, added with 5. Take the third element, added with 6. So you get a new array, which is basically addition of a and b. In fact, if you say a multiplied by b, it works very smoothly. Every element will multiply by the other element. You say a minus b, it works smoothly as well. So one element minus another element. In fact, you can also say a plus 2. Now, what does it mean? Now, it's an integer value, but here we have an array. So what we are trying to do is we are trying to add each and every value by 2. So 1 plus 2, 2 plus 2, and 3 plus 2. It gives me the new value. In fact, I can also specify a power 2. It gives me the power of each and every value. I say a multiplied by 2. It gives me the multiplication of each and every value. So that becomes so good. Let's say for example I have a, I can also apply the conditional statement on the top of it. Let's say for example I say a equals to a modulus 2 equals to let's say 0. Okay, so here I'm comparing whether a modulus 2 is equals to 0. I want to find it out what are the elements we have are even or what are the elements we have an odd. It give you me the value in a form of a true and false. So it's a modulus 2 equals to 0. No, 1 is not even, so it give me false. 2 is even, it give me true. 3 is odd, it give me false. And the type of this particular structure is Boolean. I hope it is understandable for everyone. In case if you have any doubts, what you can do is you can take a pause and again go back and check it out. What things are. You can go back and look into the slide as well. It give you more descriptive way. Here in this case, we can also create a multi-dimensional array. So by that time, we have just created a single dimension array. Now let's say for example A. So I have a very good data available over here called as endim, which basically give me the dimension of my array. So my dimension of our array is 1 only. So let's say for example, if I want to create a multi-dimensional array, how we can do that? I simply say A equals to numpy dot array. NP is my module name, and I give the square bracket which is used for defining the array, and I can give multiple square brackets inside that. Now I say 1 2 3, I say 4 5 6. Now here we go. Now this is an array which is of integer type, contains 6 different items. Now I run the same operation which I have done before for a single dimension array. Now I say a dot endim. It give me the dimension a dot shape. Provide me the shape of it, which is 2 comma 3. Total number of rows we have is 2 and 3 number of columns we have. Similarly, now you say length of A. What is the length of A? The total number of elements available. So length is 2. I have 2 number of objects available in my array. But what is the size of A? So I say A dot size. What is the size of A? It give me the size of my array. So my size is 6. Now you can understand the difference between a length as well as size. Size will give me the total number of elements which is available over here. Now I have an A available with me, which is a kind of an array we have. Now this is row number 1, this is row number 2, this is column number 1, this is column number 2. It works in a very good way in a slicing say which through which I want. So if I say A 0, it give me the 0th index, which is 1 2 3. Now if I say 0 comma 0, 0 comma 0, so it means that I want to pull out 0th index, sorry, 0th row, 0th column out of it, which is 1. I can also do like this, a 0 of 0, that's also fine. Okay, so 0 comma 0 give me the 0th index as well, 0th row as well as 0th column. Similarly 0th row as well as 0th column out of it. Now there are some slicing operation I can also able to perform. Let's say for example I say a 1 column. It's a I want a first, after first row I want each and every row. So it give me, I have only one row, in fact 2 rows available over here. So I want after first row I want all the rows. Now similarly if I say a, I say okay, what do you want? You want till first row. So I want what till first row. So it gave me the 0th row out of it. So it gave me 1 2 3, which is the 0th row of my array. Similarly, if I want to pull out the columns, let's say for example, if I want to pull out this 2 5. So what is this? This is column number 1. So how to do that? I say a colon comma 1. So it pull out the first column from this array. If I say a colon 0, it give me the first the zeroth column from this particular array. Okay. In fact, if I say a 0 comma colon, now this is quite interesting. It basically returns the zeroth row. What is my zeroth row? It's 1 2 3. But if I remove this comma, it's a after 0 and after 0, the total number of rows, return those. So I have 2 rows associated with that. So it returns 2 rows over here. So here you can be able to perform the slicing, basically pull it out the specific data of it. Let's say for example, I have a multi-dimensional structure. Let's say for example, I say numpy array. Now here I provide 3 rows, 1, 2, and 3. Okay, I say 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I did a mistake. 9. Here we go. Now my A is ready. Now it has basically 3 different rows available with me. So let's do this operation. So I want to select 3, 9, 3, 6, 9. So how I do that? I say A colon comma 2. It gives me the second row. I say A 2 comma colon. So what I want the second row. What is my second row? 7, 8, 9. Boom, I get a value associated with that. So that's a quite interesting part. Let's say for example, now what I want is here, okay, I want 5, 6, 8, 9. I want only this 4 items. So how I can proceed further? I first select the data after first row. This is my first row. So I want to select a data after first row. So I say, what you can do is you can say one column. One column will give me the data after first row. So let's run this and see this. So it give me 4, 5, 6, 7, 8, 9. And what I want out of it? I want out of it is colon, comma. Okay. I want what I want. I want the first row as well as first column as well as second column. That's tricky. So what I can do is here I can specify in this way. So I want one colon. No, not this one. So I say comma 2 will give me. Oops, what I'm doing. Here we go. This is the one 6 row. And if I want 5 and 8, I get 5 and 8 out of it. Now that's quite interesting. You can pull out the data as per your requirement and you can get it through. Now, one more thing over here is reshaping your array. Let's say, for example, here I have this shape. This looks pretty common shape, which is 3, 3, 3 number of rows and 3 number of columns. Let's do this way. So I'm introduce you first with a function that called as an arrange function. Now, arrange function is same as a range function in Python, which give me the range of some values. Let's say, for example, I say a equals to numpy dot arrange. Okay, I say to get 10 values out of it of a type integer. So a is created which has an array starting from 0 and go till 9. A total 10 number of elements we have inside this array. Now what is the shape of this array? So I say a dot shape. What is the shape of this array? It's 10 comma. The total number of rows I have is 10, but we don't have any columns associated with this, so it says 10 comma. Now let's say I want to reshape this particular array. So how to reshape it? We have a function called as reshape. How to use this? I say a dot reshape. Okay, I provide a tuple in the shape I want. Now I have 10 elements. Either I can divide into 5 comma 2. Either I can divide it 2 comma 5, or either I can say 1 comma 10 as well. So I divide into 5 comma 2. Once I say 5 comma 2, I reshape this element into 5 comma 2 and I can assign it back to some value. Let's say for example I assign it to b. I say reshape 5 comma 2. So it gives me the new b, which is a shape is having 5 comma 2. That's quite interesting. Now you can also have a membership operator inside that. Let's say for example I say 2 in b. So it basically checks it out whether 2 is available in my b or not. If 2 is available, it returns true. Otherwise, it returns false. If I want to convert this B into a list. Then I have a function called as a list, as a list of B. So it converts not each and every array, only the main array into separate list. Okay, now you can see B I have, which has array 1, array 2, array 3, array 4, array 5. So we converted this into a list of multiple arrays. Okay, it also supports the copy of it. So let's say, for example, I say C equals to B, a C is created. Now I modify C, so I say C0 of 0 equals to, I give a value 10. Okay, now C is ready, in which the first value is 10. Now if you look into B, the B will also get modified and hold a value 10 now. So it also supports a deep copy of a data, in which if you have created a copy with a direct assignment, what it does, it basically creates a deep copy, and the modification on one will be reflected into others. Okay, here we have A, which is basically an array containing 10 elements. Let's say I want to create a B out of it, as a B of 2, 4. So I start with 2 index, 0, 1, 2, start with 2 index and go till 4. So it holds 2 and 3. Let's increase it as a 2, 6. So basically I have created a B from A array while doing the slicing. Now let's say, for example, if I change the value of B, so I say 0 equals to 10. Now when I change the value of B, what will happen? The B value get changed as well as A value get changed. A value get changed as well. So what we have done is, here we have modified the value of B, which is equals to 10. Now what happening with A as well, you can see the value of A will also get changed in these cases. Now that is called as slice reference. Slice reference means whenever you modify a B value, the value of A will automatically get changed over here. Now that's an important thing to know, that whenever you create a slice of it or whenever you do the direct assignment, the value get changed. A very important point I would like to mention here, let's say for example I say A0 equals to 10.5. Now the array which we have created is an integer array. It's an integer array. Now what we are trying to do is, we are trying to modify the value of A of 0th index equals to 10.5, which is a floating value. When I say, in fact, make it 20.5. When I run this, when you try to print the value of A, actually the decimal part has been omitted over here. Why the decimal part has been omitted? Because A holds an integer. It does not hold a floating value. So that also need to be checked out whenever you are doing. Another very important point over here is, let's say for example I have A. Okay. Now in A, let's say for example I want to fetch it out this 10, this 4 and this 7. So what are the indexes I have? This is 0th index, 1 index, 2 index, 3, 4th index, 5, 6, 7 index. So I need to pull a value which is at 2nd index, the value at 4th index and the value at 7th index. So how we do that? I basically create indexes equals to, I give like this, I say I want 2nd index, 4th index and 7th index. Boom. Now I say A of indexes, A of indexes. So it pull out only the indexes available at 0th place, the indexes available at 4th place and the indexes available at 7th place, which is 10, 4 and 7. And that's one of the important point which you can notice on. Okay, that's great. Okay, one more thing I would like to discuss. Let's say for example in this particular case I want to pull out all the values which are divisible by 2. So how to do that? I say A modulus 2, okay, equals to 0. So it give me the array in a form of a true and false we have seen earlier. But I want to pull out only those values which are divisible by 2. So how to do that? I say A in indexes I provide this 2 equals to 0. So I provide a condition here for this for those value in which the condition is true, it returns those value back to me. Boom. Okay, that's also interesting point of view in which I want to pull out all the odd, all the even element out of it. Now this operations can also be achievable with the help of a function called as where. So Numpy provide you the where function, in which you can also specify the same thing, equals to 0. That also returns basically the index number, which has, now this is like a tuple, you can see the tuple here, which is having a 0th index, which contains all those elements which have a value. So if I want to pull it out only a 0th part, I can get the array indexes, which indexes, so this is 0th index, which have a value equals to 0, second index which has a value equals to 0, and fourth index which has a value equals to 0, and so on. And I can do like this, numpy dot where, and I provide a modulus 2 equals to 0, and it's 0th part. Boom. Same output I can get it out of from here with the help of a function called as where. That's an interesting function we have seen also. Now, one more operation I want to perform over here called as a flattening operation. Remember, we have created one array. Yeah, I remember I have created C, I guess. Okay, that's an array. Now, this is an array I have which have a shape. So if you look into the shape, this is 5, 2 shape. So total number of rows we have is 5. Total number of columns we have is 2. Now I want to flatten this array. Flatten means now this is a two-dimensional structure. So c dot endem is a two-dimensional structure. Now I want to convert it into the single dimension. For this, NumPy provide you the function called as flatten. So how to do this? I say flatten. Here we go. Okay. So what it does, it flatten complete two-dimensional structure and return a single dimensional structure out of it. Now it doesn't change C actually. You can hold a value. Let's say I say d equals to c dot flatten, and it basically flatten and put it into d structure now. These are the multiple functions we have seen. Let's try to see one more function called as a transpose function. Let's say I have a c value. Now this is a rows I have. These are the rows I have, and these are the columns I have. Let's say I want to transpose it. Transpose, as the name suggests, I want to convert a rows by column and column by rows. So how do that? I say c dot. I have a function called as transpose. Here we go, transpose. So once I do this, whatever the rows I have is converted to the columns, and what are the columns I have is converted back to the rows. Again, I have a c which remains same. So if I want to convert, let's say for example, I say c dot, I can also say t. That's how we can also do the transpose. Now E is going to hold a transposed element arrays we have. That's basic functions we have seen. Now maybe a lot of things is still pending. So what I can do is I can give you the last thing for today session, and maybe I can record a second part tomorrow. The next part is, let's say for example, I have an ASCII file and I want to load this data back to the NumPy array. Now let's say for example I have an ASCII file, so I take an ASCII file somewhere. Okay. There we go. Where is an ASCII file? Okay, let's say this is an ASCII file I have. Now this is a CSV data file I have. Now let's say I want to load this data. So I'm interested in 3 different columns. Let's say I am interested in price, I'm interested in dividend, I am interested in price as well. Now I want to load a complete data of this file into a NumPy array. So how to do this? NumPy provides you the function called as load.txt. So I have a function called as load.txt. The first parameter to the load.txt is a file which I want, and let's say I don't want this being a part of my NumPy array, so I can say skip row number 1, and I say skip number 1. What is the type of it? Let's say I have specified a string here because I want to take this data in a form of a string. If I want to take of this data in a form of a float, I can immediately say float value. And once I'm done with this, here we go. I provide a delimiter over here. The delimiter is comma. As this is a CSV file, everything is separated by a semicolon, comma here. And what are the columns I require? So I require 3 columns, 3, 4, 5. This is column number 3, column number 4, column number 5. So what I can do is I can take this data, run this, go back over here. Oops. I copy and paste completely fine. Okay, here we go. Oh, my CSV array has been created. This is a NumPy array which holds a data of my file. Now, whatever operations I want to perform in this particular data structures, I can do it pretty easily. This is a common uh, slide I have taken from some other slides. They say other files supported by Python. So we have seen that txt file. It is supported by Numpy, so we can load a data into it. CSV module. I think we have seen this module when we discuss about a Python. There is a module called as scipy.io input output, which basically deals with the MATLAB files. Then you have SDF files, then you have netcdf file, and if you want to load an audio file as well, there is a package called as scipy.io.wav file through which you can able to load a data from the file. And if you want to load images, it can be a PNG image or JPEG image. You have a pill, which is pillow library, image processing library, which can be used for processing the image and give you the results out of it. Maybe if I want to pull some specific data from the image, you can load this data and pull the text data from that particular image. So this is all I have for today's session. I think it's almost an half an hour session we have taken over there into this recording. NumPy is not yet finished. I have several functions need to be finished for NumPy, like mathematical functions or statistical functions, and do a lot of other functions which are used for developing, I would say, the algorithms through it. So I'm going to discuss about this session in tomorrow's session. I again record this session and put it into my repository, and I share it through the document which I normally does. So I hope you enjoy this session. It's a learning experience for you. And in tomorrow's session, I'm going to cover again a NumPy from this particular slide, and we proceed with more examples. Till then, see you. Thank you so much.